Okay, welcome, Donald and Tina and Warren and Alex and Eileen and Aria and Terrence and Guadalupe and Armando and Victor. Thanks for showing up. This is the week 9 webinar. We're close to the end now. We only have a few more weeks left, and then we call it a day or a quarter. So let me tell you the plan for now. Today's actually one of the more gentle days because we don't have any major thing coming this week. It's been a while since I've been able to say that. You took the test, and I posted the key online. So the key to the test is, I think it's in week 8. If you go to the modules, you'll find the key. If you have any questions about it, feel free to post in the Q&A forum, and I'll answer any questions about how to do any of the problems, and I'll happy to help you and explain things. Our next test is the final exam. So definitely, you want to make sure you take that seriously. And if you didn't do well in the midterm, you need to, change the way you're doing things to make sure you do well in the midterm. That might be really cranking up the amount of hours you spend working out problems and writing for this class because we're in writing stage. The other thing that's coming up, although we have a little bit of time, but it'll come up not too long from now, is we have our Project 2. So Project 2 will be coming up in November 24th, it's due. So that is, a week from Sunday. So again, it'll come up quickly. So make sure that you have your partners, and it's time to start thinking about what your project is going to be about, what your H0 and H1 are, and how you might be collecting your data. That might be with a survey, it might be just finding data, not statistics, but data. So you need to find individual answers to whatever the survey question is, so that you can't get a census. You get a census, then there's no reason to do a confidence interval or a hypothesis test. But the main thing we're doing today is we're going to be talking about what's called chi-squared distributions. What we have not done yet this quarter at all is talked about how to analyze qualitative data that's not just yes or no. And that comes up a lot. There's a lot of studies, a lot of surveys where the answer to the survey question is not a number and really doesn't work as a number. It just doesn't make any sense. Like if I asked you, what state were you born in, or what country were you born in? You can't turn those into numbers. They just don't work. And so a lot of things don't work. Or if I said, what is your ethnicity? Again, there's no number for being Hispanic or being Asian or whatever it might be. So a lot of times you have surveys and they are qualitative. And that doesn't mean that we can't do them. It just means we haven't done them yet. So that's what we're going to be talking about today, is how to look at qualitative data. And we're also going to be looking at how do you tell if something fits a distribution. Like we've talked about, let's assume the distribution is normal. You've heard me say that a lot of times, right? Well, assuming is a bad thing. So a bigger question is, can we say that it's probably normal, okay? Or can we say that it's definitely not normal? And we're going to have a hypothesis test for that kind of thing. Or is this uniform? Is it a uniform distribution? Okay, often in that whole chapter on uniform distributions, that was what, chapter 5? The first sentence was, suppose we have a uniform distribution of blah, blah, blah. And there's no reason to believe it's uniform. So we got to decide, well, how do we know it's uniform? Or how do we know it isn't uniform? We'll talk about that too. So those are the main things we're going to do today. I want to ask you, are there any questions at all about anything that's come up in the class? This is a great time. Any questions? Again, I always like to hear some questions. Any questions at all? Okay, if there aren't questions, I might jump into what we're going to do. So just let you know, in the chi-squared distribution stuff, it's pretty technical. because it's technical, I'm not just going to be able to grab a current event and analyze it. That doesn't work. I'm going to give you a bunch of problems that are kind of fabricated, because the real problems are pretty technical. But I don't know if you've seen yet, but the discussion post this week does the discussion. We're back. So there's no reason not to have a discussion post this week. Last week was midterm week. That was your focus. But we're back to discussion posts. So your discussion post will be to find a peer-reviewed journal article that does something that doesn't have to do with statistics, but uses chi-squared to be able to talk about it and provide evidence for whatever they're trying to show. So that's what the discussion forum is. And so any of the chi-squared stuff you see, you're going to see that in peer-reviewed journals. Okay, that's where we're talking about, serious educational stuff, master's degree or, high-level undergrad, which, again, you'll probably be in a couple years. And you'll see chi-squared then. You won't see chi-squared ever in the everyday world kind of stuff. I'm not going to be able to grab a CNN article that talks about chi-squared. It just isn't going to happen. But I can still make some things up, and that's what we're going to do next. So let me share my Zoom screen. I have one ready because we're not doing a current event. We're going to just run through some typical questions. So I know not all of you live in Tahoe, but I know at least one of you does because you're in my office today. But you may or may not know about Tahoe, but we kind of split our area up into the North Shore, the South Shore, the East Shore, and the West Shore. If you haven't been to Tahoe, please come because it's beautiful. And let's suppose that they counted 600 randomly selected cars in the Tahoe Basin and found 170 in the North Shore, 212 in the South Shore, 110 in the East Shore, and 108 in the West Shore. We want to conduct the appropriate hypothesis test, and we want to provide interpretations. Okay, so the first thing I'm going to ask you to maybe contribute is we want to say, well, what is the survey question? So either say it or put in your chat box what you think the survey question is. So what do you think the survey question is to this particular study? So I'm waiting for you to type it in or to say it. So what is the survey question? It's pretty simple. You don't need to know any fancy statistics for it, just to say what the survey question would be. So I'm going to give you time to think, but hopefully you can tell me. Again, you don't need to know any statistics. This is just if you were to write it, if you were to look at the survey, what would the survey question be? What are you going to? Okay, so Tanner says, is the traffic equally bad in the north, south, east, and west? Okay, that's a good guess, but that's not the survey question. That's the question of the hypothesis. Okay, the question of the hypothesis is it equally bad? And we want to find that out, but that's not the survey question. A little like when we had, say, a hypothesis test for a proportion, we want to find out if the majority of people want to vote for Trump, then the survey question isn't, do the majority want to vote for Trump? The survey question was, do you want to vote for Trump? Do you remember that? So be very careful about getting the survey question and the question of the hypothesis confused. They're different. Is the traffic bad where you live? That's not going to be the survey question either. That is a good try. Any thoughts? How long did it take? No, we're not talking about how bad the traffic was. All right, maybe I need to tell you because you're not coming up with it. It's very simple. That's a hint. Very, very simple. You're going to ask this driver, and you're going to say, what shore are you in? Right? What area of Tahoe are you in? You're going to note what area of Tahoe this car is in. Does that make sense? That's a survey question. Because notice they counted 170 in the North Shore, for example. Well, what they counted was what shore they in, and yep, they checkmarked North Shore. That was that car. Then they get to the next car. They say, that one's East Shore. You see that? So the survey question is, what shore are you in? Anyone still confused on that idea? Okay, and if you can't get the survey question, it's pretty much over for you. So you want to practice this. And not just for this problem, but pretty much every problem we do and have been doing for a while now. And we'll be doing the rest of the whole quarter. Okay, so again, the survey question is, what shore are you in? And the answer to the survey question might be North Shore. But notice it's a word, it's not a number. Any questions on that? And it's not yes or no either, because it's what shore are you in? Okay, so now what that says is that we don't know how to do this yet because we have not discussed how to deal with questions like this. So now what we want to do is we want to take this question, is the traffic equally bad in these four shores? If it is equally bad, means there's the same amount in every shore. What do we say? What's the word that we use for saying that it's equally bad? I'm looking for a one-word answer, possibly two. Different? Not quite, because different isn't equally. You want to be thinking about equally bad, not equally bad. So what's the word we use? A statistics word for that. Any thoughts before I jump in? All right, well, let me say it because you're not all guessing. Uniform. Remember, we use the word uniform if it's all the same. Do you remember that? So when we talk about our null hypothesis here, that's going to bring about our null hypothesis. So what we can say is H naught is the distribution of cars is uniform. Any questions on that? Okay, because we want to see, is it equally bad? If it's equally bad, that means you have the same number of cars in each of the four places. And H1 is the opposite. The distribution of cars is not uniform. Any questions at all on the null hypothesis and the alternative hypothesis? I want to give you a big warning, okay? Up until now, our H naught and H1, they've always been in symbols. You'll notice that for this chapter, they're in words. So what happens on the final exam is a lot of people just give up on symbols and they write words only. And that's not okay. So the alternative hypothesis always has to be the opposite. Yeah, and that's always what it is, right, Victor? Is that your H naught is the status quo, and H1 you're trying to show that the status quo is wrong. And it turns out with uniform, there's no left tail or right tail. It's uniform or not uniform. Does that make sense? So if the status quo is wrong, if being uniform is wrong, then it's not uniform. So that's supposed to be pretty simple. That's the hope. Once you have H naught, H1 is easy. The hardest part about this is to be able to decide that this is a qualitative study and that we're going to have to use this kind of hypothesis testing. Okay, that's going to be tough for a lot of you. And again, identifying the test, because now we have a lot of tests to use. So any questions at all so far? Okay, so we now have our H naught and H1. What we need now, which is totally new, is we need how to do this hypothesis test. It's not going to be a t-test because we have a t-test to look at means, right? It's not going to be like a one prop z-test or two prop z-test. It's not about proportions. Okay, this is its own thing. And what this is called is a chi-squared test. I think I'll write it in symbols first, and then I'll write it in words. This is called a chi-squared test. Okay, and there's more than one kind of chi-square test. In particular, the kind of chi-square test this is called a goodness of fit test. So when I ask you to state the name of the test you're using, this is goodness of fit. The reason why it's goodness of fit is we want to say, does the data fit the uniform distribution, or is the data way off from the uniform distribution? And hopefully you know from surveys, you're never going to be exact, or just about never going to be exactly on it when you're trying to say if it's this distribution. But if you're pretty close, you're going to say, well, we can't reject the null hypothesis. But if it's way off, that's different. Do I possibly have an exact definition of chi-square test? Yes, I know it, and you don't want to know it. It's chi-square test is very high mathematics. So I can't give you a full definition, but the chi-squared, all the tests we're using today are going to use what's called the chi-squared distribution. Okay, and the chi-squared distribution, if you want, I could do a picture, which is better than what you're asking for. If I answered your question, you'd probably all be logging off right now because it's that tough. So instead, what I can do is this. It's not a uniform distribution. It's a chi-squared distribution. And it looks like that. So that's a different distribution than uniform. Okay, any questions on that? Okay, so it looks like that, and depending on what's called degree of freedom, it's going to be slightly different, but it doesn't look uniform, it doesn't look normal, it doesn't look uniform, it doesn't look like a T, it's its own little test. Hopefully, I've said enough, Victor, that you're willing to let it go. Okay, so exact definition is going to be too hard for this class. This is an elementary stats class. But what I do want you to know is that if you have a question where you want to see if the distribution is something or is it not that thing, then you're going to use what's called a goodness of fit test, which uses the chi-squared. Okay, so I want to mention something really important, and that is in H0 and in H1, I have the word distribution. So if you're going to be doing a chi-squared goodness of fit test and you don't have the word distribution in your H0 and H1, any guess what's going to happen in the final exam? So what do you think will happen? Yeah, you're gonna lose points. That's a promise. And if you have the word distribution in H, not H1, I'll give you points. Even if everything else is wrong, I'll give you something just for saying the word distribution, for knowing that. Got it? Okay, but hopefully you can get the rest right. So we're gonna do a goodness of fit test. And when you do a goodness of fit test, things look really, really different. Okay, first thing is we have to find what's called the observed and the expected. So let me draw a table. The observed usually uses O, and the expected is E. Any questions so far? Okay, so the observed is actually pretty easy to see because that's the values that you observed. And what we observed in the North Shore were 170. In the South Shore were 212. In the East Shore, 110. And in the West Shore was 108. Any questions for the observed? Expected is not that hard either, but it's a little technical, it's a little trickier. So if it was uniform and we observed and we counted 600 cars, how many would we see in the North Shore if it's truly uniform? What do you think? Yeah, 150. And the way you got 150, for those who didn't see it, is that there are 4 different shores. And if it was uniform, it should be equally split up. And 600 divided by 4 is 150. So 150 is how many you would expect to see in the North Shore. How many would you expect to see in the South Shore? The hint is this one's really easy. Yeah, still 150 because it's uniform. If it's uniform, you're just going to see 150. And I bet you all can tell me how many in the East Shore. 150. And then in the West Shore, we should see 150. All right, so then you say, well, did we see 150 in each of the shores? Did we? Yeah, definitely not. Does that mean we reject the null hypothesis? Okay. And the answer is that's not enough. Because if you observe 600 and it was uniform, okay, then randomly, you're going to be off by a little bit typically. Like if I flip a coin a bunch of times, I'm not going to get half heads and half tails. I won't be so far away, but I probably won't get 50-50. It'll be close. Similarly, if you randomly select 600 cards, you're probably not going to get 150 in each, even if it's uniform. You're probably going to be off by a little, just like flipping a coin. So the bigger question is, are we off by little or are we off by a lot? And that's a little harder to see. So notice, for example, in this first one, we're off by 20. The second one, we're off by much more, 62. The third one, we're off by 40. And the fourth one, we're off by 42. So what the question is that a lot off or is that a little off? Any questions on that? Okay, and as you might guess, there's going to be a statistic that tells us how off it is, how likely it would be to be that far off. Okay, and what do you think that statistic is called? The hint is you should all know this one. It's the most important statistic in the last half of this class. We've been at it for a few weeks. Standard deviation, that was the first half. P-value. Yeah. So we need a p-value to find out what is the probability of being so far off or farther off than what we are right now. So then what you're also very used to, I'm sure, is you're used to going to your calculator. Okay, what you're not used to do is going to the calculator the way I'm about to show you. So let me show you, and then cross your fingers big time. So I need to reshare my desktop to calculator. Where is it? Just a minute. I think it's, what is it? Ah, there it is. There's so many things on my screen that it didn't find it. Okay, so what we're gonna do is, here's our calculator, and the first thing, and follow along with your calculator and cross your fingers. The first thing you all have, and that is if you hit stat, you edit, and we can clear out, we need to clear out L1, we need to clear out L2. Any questions on that? In L1, we're going to put our observed values. So if you remember, just a second, the observed values were 170, 212, then 110, and 108. In L2, I'm going to be putting in the expected values. The expected values are 150 all along. So 150, 150, 150, and 150. Any questions on that? Okay, here's the next thing. This is where you cross your fingers. You hit stat. We're going to go to test. We're towards the end of the class now, so it's easier to go up than down. So if you go up, you might see GOF. So who doesn't see GOF in your calculator? Anyone not see it? Alex, you said you don't have it, but now you look at it, you sure you don't have it? Okay, you don't? Okay, so you need to have it. So I'll show you some other things you can do. Wow, this is like the most that don't have it. Most calculators have it. Only the really old ones don't. But I'll show you how to use this one. I'll show you some workarounds. Then I hit enter. The observed is L1. If it doesn't say L1, I need to put second 1. The expected is L2. If it doesn't say that, I hit second 2. DF stands for degrees of freedom. And degrees of freedom is going to be the number of categories minus 1. How many categories were there in this particular problem? There are 4. So our degrees of freedom is 3. So I type in a 3. Color never matters. And I hit enter and calculate. Okay, the test statistic is 50.72. That's chi-squared. That weird little thing is not an X, it's a chi. That's a capital Greek letter. And it's chi-squared. The P equals, that's your p-value. So is the p-value 5.61? Yeah, don't ever put down a number bigger than 1 for your p-values. Okay, what am I missing when I said 5.61? Yeah, that e negative 11, it's 0.00000000561. Is that clear? So that's about as strong evidence as it gets. Any questions on that? Okay, so let me show you another way to do the same thing. Which you can't use on the final exam, but you can use in your homework at least. And that is, I got to reshare my desktop. Just a second. So as I mentioned, the Google Sheets thing that I made does pretty much everything in this class. Okay, so what you can do is you can go to chi-square tab, and then we just need a first and a second. So I'm going to erase the first and second from before. And then I need my numbers. So the first was, where are we? 170. Then we had 212. And then we had 110, and then 108. And then the second were 150s throughout. Okay, we need to hit this little arrow, and we need to go to goodness of fit. And there it is. Okay, it gives p-value of 0 because that's just basically the same thing. It's as close to 0 as you can get. Yeah, super strong evidence is a good word. Okay, but let me write down the conclusion. Any questions so far? Okay, let me show you one more thing. And that is if you go, actually, I need to go over here. Chi-squared goodness of fit calculator program. So this is a video on how to make your calculator work. It shows you step by step on how to program it. And it's YouTube. Okay, but you have to hit every button that they tell you in this 8 minutes. And that will work also. You can come to my office. I was having a real trouble with this thing. If I can get this working, then I can feed my program into your program. It takes 2 seconds if I get it to work. But I was having trouble earlier today. Sorry about that. Any questions at all so far? Okay, now let me reshare and let's do the conclusion, which hopefully you know how to do by now because we've done hypothesis testing enough. Okay, so we had tiny p-value. So you should know that when you have a tiny p-value, that means you have strong statistically significant evidence. So there is strong statistically significant evidence to conclude. And now I just restate H1, that the distribution of cars is not uniform. Any questions at all on the goodness of fit test? Any questions? Okay, let me move on to the next example. And to get to the next example, it's gonna be different. But as you might guess, it's still gonna be using chi-squared. Just a second. I need to select. Come on, let me have it. There we go. That's better. Okay, so here's the next question. A study was done to see if there is a difference in the distribution of cars for men and women. Of the 200 men surveyed, 700 owned a foreign car, 110 owned an American car, 20 didn't own a car. Of the 300 women surveyed, 110 owned a foreign car, 158 owned an American car, and 38 didn't own a car. Conduct the appropriate hypothesis test and provide your interpretations. So let me ask you, how does this differ? How does this differ from the one we just did? There's one big difference. Any thoughts? Give you a minute to tell me. So how does this differ? They conducted 2 surveys, right? They got 2 surveys, but what's the big thing about it that we had last time that we don't have this time? So Victor, you're right. They conducted 2 surveys, and that's a big deal. But something we don't have this time that we had last time. We thought subcategories. Well, we got our categories. We got foreign. We got American. We did not own a car. We had that last time, and we have this time. Same question. Okay. But not, we have 2 different expected values. Not quite. Maybe I should mention it. The big difference last time that we had is we were saying, is this uniform? We had a distribution to compare. Here, we don't have any distribution. We don't know the men's distribution. We don't know the women's distribution. And if they're not uniform, that's fine. But what we want to find out is, are the distributions the same or not? We're not comparing a known distribution to an unknown distribution. We're comparing 2 unknown distributions. Do you see how that's different? So if you remember, the key word last time that I said you must have is distribution. The key word this time is distributions, because we have more than one. So in these 2, wait till you see the next one. So for the last one was distribution. This one's not distribution. This one's distributions. Do you see that? That's a difference. It seems subtle, but it's really important. So let me write that out. The distribution the distributions of car ownership type is the same for men and women. I forgot to write, which is really important, H naught. Any questions on that? The good news for H1, if you're typing like I just did, it's really easy because I just did copy and paste. Hopefully you all know I got to change the not to a 1. And what else do you think I need to do for an H1? And actually, even there, I made a little mistake, but it's minor. This should, oh shoot, I forgot to, let's go Control Z. Little mistake on H naught, which is really minor, but some of you might be bothered by it. 2 of them, so R, better grammar. So for H1, what do you think I need to put in? The hint is similar to H naught, but not exactly the same. Yeah, just got to throw the word not. So the distributions of car ownership type are not the same. If you want, you can call it different, but if you're copying and pasting, not's easier. Any questions at all so far? Okay, we don't have observed and expected this time, but what we do have is we still can draw a table. And one of the things that is going to be consistent tonight is tables. Everything is going to be table-based. So what I'm going to do is I'm going to go and draw a table. And the table, I'm going to have the men. And the men's values were 70. And then we had 70 for the foreign, 110 for the American. And then we had 20 for no car. And then we do the same thing for the women. But how about just space? So WM is good enough for women. And for the women, we had 110. We had 158. And we had 32. Any questions so far? Okay, this is going to be very different in terms of the way you do it in your calculator, but real similar in like H0 and H1 are real similar to what we just did, but it's distributions instead of distribution, and you're comparing one thing you don't know to another thing you don't know. So now I'm going to go to my calculator, and the good news is all the calculators have it. The 83 has it, all the 84s have it, the Nspire has it. They all have this particular one. They just don't have good as a fit, unfortunately. Kind of a bummer. Okay, I mean, some do and some don't, but they all have this one. So let me share my desktop to my calculator now. So I can clear out what I had. Now we're going to do something that we haven't done in this class, and that is we're going to go to second matrix. Then I'm going to go to edit and hit enter. Our matrix, if you remembered, had 2 rows. So I put a 2 there, and it had 3 columns. Any questions so far? Okay, next I need to put my numbers in. And if you remember, the numbers were 70, 1, 10, and 20 for the men. So 70, enter, 110, enter, and then 20. And then for the women, it was 110, 158, and 32. Any questions so far? All right, so I have my matrix. Let me show you what we do next. The next is going to be a lot more familiar. We're going to hit stat. Then I'm going to go to tests. I'm going to go up arrow. And we're going to go to chi-squared test. Notice that's different than the GOF. And all the calculators have the chi-squared test. All the TI, 83s, and A4s at least. And I'm going to hit enter on chi-squared test. Observed is A. Expected is B is fine. Don't worry about that, but observed has to be A. Color never matters in this class. Okay, and then I hit calculate. And there we have it. What do you notice? Yeah, now we have a p-value of 0.88 about. Okay, it's a very high p-value. It's not even close to any level of significance that you'd ever think about. Our chi-squared, which is 0.266, and in this class it's going to be hard to understand really what that means, other than it's the test statistic. Just like we had a z or a t, now we have a chi-squared. But our p-value, you should all understand, is 0.875567. I want to show you something. If I go back to matrix, and I go to B and hit enter, and enter again, you'll notice that we have the entries for B. So just like we did when we had proportions, we had to make sure everything was bigger than 5 for proportions. Now we're going to make sure everything's bigger than 5 for this B. And if everything's bigger than 5, then this test applies. If anything is lower than 5, then this test can't really be used. Any questions on that? Okay. And similarly, I didn't mention it before, but in the goodness of fit, all the expecteds have to be bigger than 5 to be able to use the test. That was just a note. Okay, so we had a really high p-value. So now we can go back. And we should, and hopefully you all can do it, we should be able to understand how to write our conclusion. And hopefully you can all do that. Maybe you can write the first couple words on it. I'll let you write the first few words, I'll write all the rest. You should all be typing. Yeah, there is insufficient is how you start. There is, and I like to write statistically, insignificant. evidence to make a conclusion. And it's easier to just write whether or not the distributions of car ownership type are the same for men and women. So if you use whether or not, then you could either say the same or not the same. It's your choice. Because whether or not gives you that could be, could not be. In other words, we don't know anything. I want to mention one more thing that's really important, and I didn't mention at the very beginning, I should have, is the name of the test we're using is called a test for homogeneity. No, I should change the color because it's blending in too badly. There we go. So it's called a test for homogeneity, whereas the other was a goodness of fit test. And they're different, and I do ask you for the type of test, and you have to write down what you're using. Any questions at all so far on these tests? Notice, again, this is another one that's a qualitative study, because you're asking, what kind of car do you have? Ah, I have a foreign car. I don't know what y'all have, but I have a foreign car. I have a Subaru, four-wheel drive, of course, because I live in Tahoe. Any questions on that? So the type of test is a test for homogeneity, and the conclusion is there's statistically insignificant evidence to make a conclusion whether or not the distributions of car ownership are the same for men and women. Okay, let me get rid of this and we'll go to the final type. And let me do another example. Okay, so here's the question. Is there a relationship between the day of a week a person is born and the type of smartphone they own? Okay, the table below shows the results of a study that was recently done. Conduct the appropriate test and provide your interpretations. So we have our days a week, we're Monday through Sunday, and our smartphones are iPhone, Android, or some other kind of phone. Okay. How is this one different from what we've done before? From the last two? Yeah, we're looking for a relationship. We're not comparing distributions. We want to say, is there a relationship? Another way of saying this, which you must have as a word, is are they independent? The day of the week a person was born and the type of smartphone. Are they independent? So qualitative area, the others were qualitative also. This, again, today is the qualitative day. Does that make sense? Right? Because the other was, what kind of car do you own? Ah, foreign. That's not quantitative. Okay, and similarly here, you can ask two questions. What day of the week were you born in? And you're going to ask, what kind of smartphone do you have? Right? I got one of these old smartphones. So any questions on that? So we want to find out if the category of day of week born and smartphone type, are those independent or are they dependent? When have we heard that before? This whole independent dependent thing. And the hint is you have to have a really good memory for it. Definitely not last week, but it was a good try. You have to have a really good memory. And last week, hopefully you all remember what happened last week. Yeah, chapter 3. Yeah, that was chapter 3. Okay, and it turns out for chapter 3, we just looked at Saturday versus Android, for example, and decided they were independent. Now we're combining all of the different entries, and as a totality, do we have independence? So it turns out the test we're going to use combines all the different independences that we looked at before together in one shot and gets a p-value for it. In chapter 3, we didn't understand what p-values were. Now we do. I'm not going to get into the mathematics because we don't do that in this class, but the mathematics takes that stuff we did in chapter 3 and kind of combines it all and then gets a p-value. So just trust me. So the first thing I'm going to write down is we're going to be using a test for independence. Any questions on that? Okay, the next thing I'm going to do, once I recognize it's a test for independence, it's actually pretty easy what I have to do next. First, I'm going to write X naught, H naught, and that is a day of, let's see, how about, let's call it birthday. As in 2 words, because it's the day of the week you were born. Okay, birthday and smartphone type are independent. Any questions on that? Okay, and you're used to this before. For H1, I can copy and paste and just change a couple things. So make that H1. What should I do to change it? I could do not. I could do even better than that. We've seen this in chapter 3. I can get rid of the in. Does that make sense? So I can say birthday and smartphone type are dependent. Okay, it's kind of like if you believe in astrology, you know, when you were born changes your whole life and all that stuff. Okay, and I'm sure like your whole life got changed because the day of the week you were born on, you know, was whatever day it was, and that, you know, you live by that, right? Okay, I'm sure you do, right? Okay, so anyhow, here we go. So notice this looks very different than the others. It doesn't have the word distribution or distributions. Y'all agree? We got a big fat table instead of like just two rows or 2 columns. Okay, but it turns out this is actually very similar to the test for homogeneity, and it's exactly the same in terms of the mathematics. And because of that, we use the calculator in exactly the same way. But what you have to know is that the H0 and H1 are very different, and the name of the test is very different. So what I'm going to do now is I'm going to do a new share. I'm going to go into my calculator. And I'm going to go to, let's clear what I had. I'm going to go to matrix. Remember, it's just like homogeneity. And then I'm going to go to edit. And you hit enter on A. And we don't have a 2 by 3 matrix. Now we have a 3 by 7 matrix. Any questions on that so far? And now we're going to type in all 21 numbers. So 75, and then 72, this will take a bit, 68, 77, 70, 86, 80, and then 120, and 111, 131, 125, 118, 124, and 101. And then finally for the others, we're 45, 52, 44, 50, 57, 46, and 52. Any questions so far? Any questions? Okay, so now I'm going to do just like I did before with homogeneity, even though it's independence. I'm going to go to stat. I'm going to go over to tests. And I'm going to scroll up again to chi-square test. Not GeoF, it's chi-square test. I'm going to enter. Observed as A is fine. Observed as expected as B is fine. And I go to calculate. Okay, so we have a chi-squared is 9.059. That's our test statistic. And then we have P equals 0.6978 about. How do we use that? Any thoughts? How do we use this information? Yeah, we failed to reject. We have a p-value that's almost 70%. Okay? If there's a 70% chance that it just would happen naturally, you're not going to say, well, that's too weird. No, you're going to say, 70% is going to happen naturally. Well, probably happened naturally. It might have. Okay, we can't say it did happen naturally, but we're going to say there's no reason to say it didn't. So that's what the p-value is all about. It gives you a probability that if the alternative, if the null hypothesis were true, if it were independent, then we get some numbers that were so far from looking independent. And there's a 70% chance of that, so it's very normal for that to happen. So we're going to say, yeah, it could be independent. We don't know it is, but it could be. So now let's write down our, and by the way, we could check, because it's quick. We go to second matrix before I write down the conclusion. And I go to B, enter, enter again. And you'll notice that all the numbers are bigger than 5. Any questions? Okay, so now I can go ahead and go into my new share into Paint, to the board. Let's try again. There we go. And we can state our conclusion. So we can say there is statistically insignificant evidence to make a conclusion whether or not birthday and smartphone type are independent. You can say independent or dependent. It doesn't matter if you have a whether or not. If you're rejecting the null hypothesis, then you say there's evidence to show they're dependent, period. That's all. That's what you say. Any questions at all on this example? Any questions? What do you think the hardest part is of this particular chapter? Any thoughts? Yeah, figuring out from the beginning. At the very beginning, it is knowing what kind of test to use. That's the hardest part. Using the test is pretty easy. It's not hard to write down the conclusion. If you know which test to use, you just got to remember if it's independence, better have the word independent there in H1, H9. If it is goodness of fit, you better have the word distribution. If it is homogeneity, you better have distributions. Otherwise, it's not that hard, but if you get the test wrong, you're screwed. Yeah, it's up there on the screen. Test for independence. Victor, do you see it? Yeah, so the test for independence. We've had goodness of fit, test for homogeneity, and test for independence. Those are the 3 tests for today. And they're all, again, they're all qualitative kind of survey questions. Okay, so secret word is distributions. So in homogeneity, I guess I picked on the middle one, you have to have the word distributions in there. So I figured I'd pop that as a secret word. Okay, so that's about it. Again, this is not one of the huge weeks where I have to go over a test, or, that we're about to take, or, the project is not due in 3 days or anything, or even the draft. But this, the chapter does take some work. It's not usually thought of as the hardest chapter, though. So it's a little bit lighter week, which is good because officially we only have a 4-day week. I know with online classes, I don't know what that really means, but we only have, that's why Tuesday. Next week we'll probably do Monday unless I hear otherwise. But we'll probably do a Monday one because we did Tuesday this week. And the week after is we do nothing. It's Thanksgiving week. And we take the whole week off. So any questions at all? I think I'll unshare and go on to any Q&A you might have. It could be about the project, could be about the tests we've been doing, the homogeneity or independence or goodness of fit, or whatever you want to ask. This is a good time. Unmute yourself is fine, talk. You can say goodnight if you want to also. Any questions? And I just want you to know, make sure you pay attention to these webinars. I write out just like you're going to have to do on the exam, on the final exam. Have you noticed I don't know if you noticed, but the webinar is one of the best ways of studying for the midterm, because I go through word by word how you do an analysis of one of these tests. So the final is going to be similar, is that you definitely need to pay attention to the webinars, take good notes, and make sure that you can do these problems. So that's really, really important, because the final exam is going to look like that. It's going to look like, the answers are going to look like what I've just written. So some of you said, well, the homework didn't really prepare me. And no, the homework isn't enough. You have to do the webinar, and the discussion forum are really important. Okay. I could talk about the essay if you want. I went over project 2. Oh, offering reviews for the essay. Oh, you mean for a draft? Like if you send me your draft, is that what you mean, Victor? Yeah, yeah. So the rule is that if you send it to me by 8 a.m. on the Thursday before it's due, then I'll read it. If it's after, I will not read it. But if you wait till the last minute, like 7:59 a.m., you're last to be read, and you may not have enough time to actually do anything about it. So the earlier you send it to me, the more time you'll have, because I do a first come, first serve. First one that sends it in, I read and give you suggestions based on it. And they're long. It takes me a long time to read through these. So, if you wait till towards the end, it might take me a couple days, which is already pretty late. So earlier is better. How did I get 150 for the expected value? Okay. All right. Values, actually, because expected value means something different. So it was pretty simple, but again, you could have missed it easily. What I did, if you remember, there were 600 different vehicles that were looked at, and there were 4 different locations. There was north, south, east, and west. And 600 divided by 4 was 150. Because the idea is if it's uniform, they should all be the same. And if they're all the same, and there's 4 locations, then you divide the total by 4, and that's how many everyone gets. So I posted it in the chat box in case you wanted to see the formula. That make sense, Guadalupe? Okay, yeah. So it's easy or hard. It's easy if you know what to do, and it's impossible if you don't. That's how it always works. That's kind of this class. Any other questions? So fail to reject is basically saying you lost the argument. Yeah, so but actually it's a little weird. You never admit defeat. So reject means you won. That's absolutely correct, Alex. If you reject the null hypothesis, you won. Fail to reject means that you're not able to brag about winning. You just kind of go home quietly. Do you see the difference? You never say your opponent won. You just say, I don't have evidence to know what really went on. Do you see?
Larry, with that, you never admit that like you tell them that they won. Does that help, of course, research the problem scientifically? You have a hypothesis that's not, you can't prove it right, but you don't want to give up on it because there's still areas where you're trying to prove it wrong?
Well, it might be that
different?
the sample size is too small. Does that make sense? So if you only looked at, say, in the car example, if you only looked at 30 cars, then your sample size is probably too small. Even if you had over 5 each, it might have been 6, 6, 6, and 6, right? Or something like that. But your sample size might have been so small you weren't able to show that you're right. Doesn't mean you're wrong. Do you see that? And by the way, a word you should never use in this class is prove. So you never prove you're right. You find evidence to support the claim that you're right. That's really important. You say it's statistically significant, which is not the same thing as proving. Because remember, one error can still happen. And proving means no errors ever happen. I could prove the quadratic formula, and it is correct, period. Does that make sense?
Yes.
But in statistics, never proven anything. All you're doing is saying, I'm very confident. But you're not saying that you're right. You're just saying, I'm confident. It's very unlikely that I'm wrong. Do you see the difference?
Oh, yeah.
Yeah. Whereas quadratic formula is right, because I can prove it. Do you see that?
Yeah, I've got pages of quadratic formulas sitting in front of me. I got that.
Yeah, that's something you can prove, or at least I could prove it.
Thanks, Larry. Have a good night.
You too. Have a good night. Any other questions? Alex or Warren or Guadalupe, Armando, Victor, Constance, any questions? Any questions? Okay, but make sure you really pay attention to the wording that I put in all these for all the webinars, because that's what you have to do on the final exam. What chapters we cover in the final exam? Chapters 1 through 13, so all. So final exam is comprehensive, which means everything is in it. You won't see every detail of every chapter, but definitely you need to, it's where I find out whether you got the course. So it's the whole course. Any other questions? Okay, you two have a good night, Victor. And Warren, Alex, Guadalupe, Armando, Constance, any questions? Have a good night, Alex. Okay, you two have a good night, Guadalupe. All right, have a good night, Constance. Armando, Warren, any questions? Yeah, always a good idea to listen again, and maybe to all of them to, practice for that final. So have a good night, Armando. And Warren, I'll wish you good night unless you have something to say. Okay, for all of you watching this as an archive webinar, have a good night, and don't forget to post your null hypothesis and alternative hypothesis that you and your partners have decided on onto the Project 2 webinar, Project 2 discussion board, so that I can take a look at it and let you know whether it works or not. And you should look at the discussion board on what I've told other people in terms of what works and what doesn't work. So have a great night, and it'll probably be Monday next week. So have a good one.